change my speakers here.
All right. Well, I have 2 o'clock, so I think we're going to get started. Everybody from Oracle ready?
Think so.
Yep.
Okay.
Yep.
Hey, Bill, real quick, how many do we have online?
We have 22 people attending, and then, of course, that's 5 panelists.
Okay, great.
All right. All right. Welcome, everybody, to our 3rd in our Virtual Tech Exchange series this summer. We've had one on just a general blockchain on, what was it, June 26th. Then we had IBM presenting on July 10th on the IBM platform and their solutions. And today we are fortunate to have Oracle. We have Jason Willis, Josh Tatum, Mark Milovich, and Rajesh Dasari to tell us about the Oracle approach to blockchain, their platform and their solutions and use cases. If you guys have any questions you want to have answered by the end, we'll do a Q&A. There is a Q&A button at the bottom of your screen. You can click on that and post whatever questions you'd like, and then I'll keep track of them, and then at the end we'll take some time and go through as many as we can. Remember that we have one more in the Tech Exchange series this summer, and that is on August 7th. That will be me providing an overview of open source blockchain development and solutions. Okay. All right, so without further ado, we're going to get started. I'm going to throw it over to Jason Willis at Oracle, and he can introduce their group and get things rolling.
Hey, good afternoon, and thank you, Bill. Appreciate it. Thanks to everyone that's online today joining us on this very nice Friday afternoon. So today we brought everybody together to talk about Oracle's blockchain platform. So Oracle's blockchain platform is based on open standard. It's a robust solution, and we currently offer blockchain solutions for on-premise, cloud, and SaaS applications. So just a quick bit about me. So I'm an account executive with Oracle National Security Group. I'm responsible for software and engineered systems business to the Maryland Procurement Office. I'm joined today by Josh Tatum. He is a solutions engineer with National Security Group. And as Bill mentioned, we also have Mark Milovich, Senior Director of Blockchain Product Management. We're also finally joined by Rajesh Dasari. He is with Oracle Consulting, and he'll be providing the demo towards the end of the brief. That being said, I'd like to pass it over to Josh, and we'll just dive right in.
All right. Hello, everybody. So Jason already gave us our basic agenda, but I'll quickly cover it here. I'll be covering the enterprise blockchain landscape and overall Oracle strategy with blockchain. And then at that point, Mark will take over, talk about our capabilities, advantages, some customer use cases. Then we'll have a demo, and then we will take some time to discuss some of our more innovative stuff, like establishing blockchain tables in a database. And then we'll close by helping you initiate your blockchain journey with some pointers and then a Q&A session. All right, so I'll give a quick brief description of blockchain for those that don't know. So fundamentally, blockchain is about establishing trust on data that is shared between partners over a network, okay? I want to have 100% guarantee that the data I send to you and the data you send to me is 100% trustworthy. Unfortunately, humans are not trustworthy, and that's why we have blockchain. And blockchain accomplishes this in 4 main ways. First, it has tamper-proof data. So transactions can't be easily changed or manipulated. There's also signed transactions that provide non-repudiation, and it overall enhances trust because it's a decentralized single source of truth. And why is that? It's because it's shared and transparent, meaning that it has multiple copies that spread to everybody. And this also enables real-time visibility and reduces delays and being able to see changes. And this is also a really important point. Number 3 is that it's consensus-based. Changes to the ledger cannot be made unless everybody on the network, or at least the majority, sign off on it. There needs to be consensus. This is also backed up by smart contracts, which think of this as a rule book. Everybody has to follow the rules. Data has to follow the rules. Nothing can be done in the ledger without being granted by the smart contract. Then we also have security and privacy. No one can even view the data, manipulate the data. You can't do anything with the data unless you are added to the actual network itself. And there's also channels and private data collections that enable more granular control and isolation between subnets. Okay, and these are the key building blocks of blockchain. Now, there are two different types of blockchain. There's permissioned-based and permissionless blockchains. And the main difference between the two is that in a permissioned blockchain, you have to be invited to the network. You're invited there, and once you're there, you have rules that you have to follow, and that's permission-based. Permissionless is everyone's invited to the network, it's fully public, and that's when we get into cryptocurrency. Here we're going to be discussing permission-based because that's by far the most advantageous to the enterprise or just to the mission in general. And in this system, once again, kind of what I was talking about, there's a shared ledger in the network. You've got your smart contracts or essentially rule book where everybody has to follow the rules, privacy and confidentiality and how that data is managed, and everybody has to approve any type of change to that ledger, and you have to be invited to it. Now, blockchain, when it does work, it does. It's a fantastic technology when it's implemented correctly. But the key word to that, though, is that it needs to be implemented correctly. And when blockchain first came out, it had kind of this gold standard. I like to think of it like kind of matching shapes in a puzzle piece. Like, so if blockchain's like a block, only certain architectures actually work for that. There are a lot of customers that, due to different types of requirements they have in their system, I like to think of it like maybe they're a triangle and the block in the triangle just does not work. And that's something that we at Oracle are trying to change in a fundamental way. And for me to kind of answer that, I'll first describe what our vision is. So here at Oracle, we believe that blockchain can enable rapid development of your network or significantly optimize your current network with all of the benefits that blockchain brings. And we think that it should be easy and quick to enable at the enterprise level. And how we achieve this is by making multiple implementations of blockchain, not just the gold standard square shaped piece. If you've got a triangle shaped architecture, then we're gonna make an implementation that's shaped like a triangle to fit. And I'll make a quick overview of what some of those are. So these are the ones that we will be covering today. In the top left, we've got our blockchain platform cloud. So this is a customer that is the perfect blockchain customer. They have their architecture all set. They have their partners already. They've got expertise with blockchain engineers. They know what they're doing. And this has all the bells and whistles that you need in a blockchain platform. It's Hyperledger based, and we at Oracle have even made our own improvements. We'll talk about that later. But then there's customers that need it on-prem. They want to have it, they want to manage it themselves. They want to have it with custom code and all of that, maybe even establish it for multi-domain. And that's what that solution is in the bottom left. And actually the demo that we'll be showing is built on that. Then we've got customers that say, okay, I don't want to touch any Hyperledger code ever. I don't have any blockchain expertise, but I want to get engaged with blockchain. Is there something that will just build the Hyperledger code for me in like a SaaS app? And we provide that with intelligent track and trace. And we've had a lot of customers in that space. Then we also have customers that have said, okay, we really want to establish blockchain technology, but there's just no way blockchain networking will ever work. But I do have a database. And we've got an implementation for that, which is one of our newer releases that's coming, which is blockchain tables. And we'll dive into that further as we have time. But right now I'm going to switch it over to Mark.
All right, thanks, Josh. And so I'm going to, let me see if I can control this. Okay. I'm going to talk a little bit about how we actually accomplish some of those objectives that Josh was talking about. As Josh mentioned, there is a lot of moving parts. Underlying the blockchain as we know it today is a ton of research that initially you can trace back to 1970s computer science work in some cases. So there is a lot of work on distributed systems and notions of distributed consensus, distributed state machines, and so on. There is a lot of cryptographic work that goes back to some of the initial, things like cryptographic hashes and PKI technology. One of the things that blockchain has done is taken what used to be fairly esoteric and required a lot of extra work to use in your applications, PKI and digital signatures, private public key encryption, all of that, and built it in to the system from day one, right? So all of that's kind of built in, but there is a lot of different moving parts and dependencies that need to be configured. And so if you start with an open source environment, you'll find that you have to add to it a lot of additional components. So we have done at Oracle to make blockchain easy for our customers to adopt, whether it's a government customer or enterprise customer, is to pre-assemble, harden, and create automatic provisioning across all of the different capabilities that you need so that you can essentially get a full blockchain environment and full blockchain experience in a matter of literally minutes, whether you're using our cloud environment or on-premise environment. There is a provisioning manager that prepackaged, that has everything prepackaged and allows you to go ahead very quickly with the blockchain infrastructure. In addition to making it easy to deploy, we're also making it easy to integrate. A blockchain, by definition, needs transactions and data to share, and that comes from your back office systems. So making it easy and quick to integrate through REST APIs, SDKs, variety of adapters, all of those things is very important so that you can actually go ahead and start using the blockchain for real missions or business critical applications and so on. And so we make all of that as straightforward and quick as possible. You have to secure the blockchain, and that means identity management, managing, governing your membership, and then once you have general access to the network as a member, governing access control on chain, what parts of the blockchain you have access to, what data you can see, what functions you can invoke, and so on, through what we call fine-grained access control mechanisms. You need to be able to monitor and manage this now that you have mission-critical applications using and running on it. You need administration, you need monitoring, troubleshooting, all of those things should not require a PhD in blockchain to make it work. So we built a lot of administration and tooling to make it very easy, and DevOps REST APIs to make it easy to integrate into your existing management and control systems. We also built in high availability, resiliency, and full lifecycle management in terms of updating and patching to make sure that all of those things are very straightforward and your general kind of enterprise software admin can handle that. We also provide some unique integration for when you need to be able to do some analytics or other kind of business intelligence on your data that sits in the blockchain without requiring complex development work to enable that. That's all built in to our capabilities. And then finally, easy to extend it to new members. Blockchain is not a static thing. You're going to have an initial network that might have a few initial members, but you might need to extend it to other organizations, and they need to be able to deploy it in different topologies, some on-prem, others in cloud. Maybe it's a hybrid environment. Maybe some of them are using non-Oracle versions. I've heard you had some presentations before from IBM and Microsoft. We provide full interoperability with both IBM and Microsoft Hyperledger Fabric blockchains so that there are heterogeneous networks can be established using nodes from multiple vendors. And we in fact have that in production today in some cases already. So we try to focus on making the entire lifecycle journey from provisioning all the way through going to production and extending and scaling out your deployment as easy as possible and as smooth as possible. Now, what is our blockchain platform? As Josh mentioned, it starts with open source Hyperledger Fabric, which is a project on the Linux Foundation. You probably already heard about it from others. Over 250 members. It's the premier enterprise-grade blockchain technology out there. There was a recent survey from the University of Cambridge that found that in production live blockchain networks, 49%, about half, use Hyperledger Fabric, right? And the next closest, I think, was scored for maybe like 10 or 15% of those deployments. So we start with Hyperledger Fabric, but we don't stop there. You have to bring in a lot of additional components. And if you see below, this is a picture in our Oracle managed blockchain as a service cloud, but all of the same components are also prepackaged in our enterprise edition as well. Once you have this entire environment running, we also have, as I mentioned, the ability to interoperate. It's an open environment. We follow all of the Fabric related standards and provide full compatibility, so you can interoperate with other non-Oracle instances, whether they're running open source or running as a vendor's Hyperledger Fabric. We provide a lot of integration points. I mentioned REST APIs, enterprise adapters for various applications, Oracle or applications, third-party applications, on-premise applications, etc. And SDKs that allow you to build clients, very rich clients in Go, in Java, and JavaScript to interact with the blockchain as well. We put in a lot of enterprise-grade features, some examples in membership governance, fine-grained access control. There is a tension in the blockchain environment about transparency and sharing the data across the ledger, but at the same time, you obviously want to enforce privacy, confidentiality, and those kind of requirements so that not everybody who is a member of the blockchain can see everything, right? You want to sort of segregate and subnet, and that's where the capabilities that Fabric provides help, but they're not sufficient. So Oracle has invested in building additional security measures and access control capabilities in there. We've also created ability to interact with the blockchain through a set of DevOps APIs to be able to integrate it into any kind of control systems you might have, not just for provisioning, but configuration and management and monitoring, extracting metrics, and all of those things are completely automated. So this is basically what our platform looks like. We have, as I said, done a lot of work to enrich on Hyperledger Fabric while still maintaining full compatibility with open standards. All of the provisioning stuff, both in the cloud and also our on-prem provisioning. Integration with identity management, that's very important. For on-prem, we use LDAP. We also support Microsoft Active Directory and a variety of other directory services for authentication and authorization. Fine-grained access control, which we've recently added. We provide an API gateway to make it easy to interact with the blockchain from a programming perspective. You can do event-based interaction, bidirectional, so you can consume blockchain events as well as trigger events into blockchain and invoke transactions. And you use REST APIs for most of that. So you could do synchronous invocation as well as asynchronous invocation. And that helps to not only simplify a lot of development integration, but it also insulates the application components you build from the underlying changes as the platform evolves. And open source like Hyperledger Fabric evolves quite rapidly. There is a management and operations console that is very intuitive and easy to use, been rated by customers as the best in the business, provide a lot of configurability and very simple ways of setting policies and doing kind of administrative tasks, creating channels, setting ACLs, etc. We replaced the underlying open source storage databases, which were inadequate from our perspective for significant enterprise use with BerkeleyDB, which is an embedded key value database, but it also provides a SQL layer on top. So you can actually, in your smart contracts, use SQL to interact with it. And then we also added a data pump to pump the transactions that come into the blockchain ledger to a relational model, relational database. So you can connect analytics and other tools and make it easy to explore the data. We have a console that provides this administration configuration capabilities I mentioned earlier. So things that you would need to do in terms of managing the Fabric network are done right in there. It provides dashboards for monitoring and troubleshooting, topology views, etc., and ability to interact with smart contracts in terms of lifecycle management, deploying, defining policies, privacy requirements, and those kind of things on them. So that's all can be done through the console, but everything here can equally well be done through the APIs. We have a number of unique benefits that I mentioned, some of them already. The SQL support, for example, in the rich data queries helps enterprise developers to write complex queries. Data visualizations and reporting, as I mentioned, streaming transactions into Oracle database, and being able to then apply analytics, whether it's Oracle or third-party tools. We focused also on simplifying onboarding. So you can have different tiers of members. You could have members that are going to have their own nodes. They stand up and they join the network. But there are some low-tech member organizations that do not have the capability and want to simply be registered as a client, have a certificate issued so they can sign transactions and query the data without having to deploy their own infrastructure. And we support that as well. So not every member needs to have a dedicated node. The access control list I mentioned as well, which provides stronger confidentiality and privacy support. And this is on-chain access control list, which means that any new ACLs created or changes or updates to those ACLs are registered in blockchain and benefit from the same immutability properties as the rest of the data that's on the blockchain. So you have full audit trail built in for any access control changes, and it's all done through the blockchain transactions. Bidirectional integration through the REST API, which is strong capability, but it's extended now with event-driven architecture. So you can use the REST API to subscribe to events from the blockchain and then trigger callbacks from the blockchain when those events happen, whether it's a transaction update, a new block generated, or custom events that are published directly from your smart contract business logic based on certain business rules. And then finally, this interoperability and ability to set up global sort of network topologies that are very flexible and meet variety of diverse requirements. If you're going to have an extended network with your partners, they might have particular requirements that they need to meet, and we can pretty much support all of those given the flexibility available in terms of network topologies and different ways of deploying it. So I'm not going to go through each one of those slides. You'll get the deck and you'll see the details behind these items that illustrate all of those points that I just mentioned. So let me just move on to this slide. Just to highlight on the integration side in particular, I talked about the gateway, API gateway. There's actually a number of ways of interacting with the blockchain technology, right? So you can use the client SDKs, which are Hyperledger Fabric standard SDKs, to interact with events, subscribe to transactions, invoke transactions, and so on. But this is asynchronous. And not every developer is comfortable using asynchronous implementations. So in the REST API, you can use synchronous transaction invocation. Very simple, very basic REST call, and you get a response back. But you can also subscribe to events, and that allows you much more capability to run in a kind of a bidirectional integration mode, because once you subscribe to an event and specify the callback URL, that can be invoked whenever a particular event happens, right? And there is also provisioning and operations and configurations APIs. But if you don't want to do that, we actually provide an even easier way of integrating through our integration adapters. And this is available in our integration cloud and our source services on-premise, where there is a lot of adapters for Oracle and third-party applications and technologies. It could be as sophisticated as an adapter for Oracle ERP system, or as simple as an adapter that takes a file coming in, parses it into records, and then stores those records on blockchain. So there is a variety of things: messaging systems, queuing systems, databases. A lot of those adapters are also available. Now let's talk about the on-premise edition, because I think for your requirements and your mission, that's probably going to be the more useful environment. This is based on the same core functionalities that we provide in the cloud offering, but it's available for deployment in your data center on the virtualization platform. So VMware, Oracle VirtualBox, Linux Virtualization Manager, all of those are available. It has the same enterprise-grade high availability, so you can deploy it and spread it across multiple machines, VMs, and so on for HA, and also for dynamic scalability. You can control and extend it, the scope of it, depending on the workload requirements. It has a provisioning manager that with a few clicks allows you to create the same full environment, very simple and prepackaged. Full feature parity with the cloud, so you could do development and testing maybe in a cloud environment, and then for production run it on-prem. Some customers do that. And as I said, support for multi-cloud or hybrid kind of environments as well. Same core functionality, same core package, but running on top of VM hypervisors that I mentioned earlier, right? With all the same benefits and integration points. The way that you deploy it is you use one of the virtualization options. You bring up this VM that we provide, which is a platform manager. And then from there, you define your network and you define your deployment shapes. There is a developer type shape, an enterprise type shape. And enterprise shape has multiple VMs, developer shape, everything packaged in a single VM to make it easy. And you specify where you want to run those VMs. And then you basically create an environment that runs in that context. And you can deploy this in a single data center across multiple data centers. And there is different topologies here that you can use, particularly when you have different security zones or domains or different organizations involved, let's say between your organization, maybe other parts of DoD or maybe other government agencies, or even organizations in other countries that you work with, right? So you could have different organizations here, some running under the same platform manager, others running on their own platform manager. and you can create those instances. And once those instances created, then they can join into, in this case, a development blockchain within a single environment or a production blockchain across those multiple environments, right? And all of the Hyperledger Fabric blockchain protocols apply here, but the nodes are running in different environments in different contexts here. And that's very helpful, I think, in those environments where you have different domains around security levels, security zones, or different agencies involved and so on. And the way to deploy it is basically there is kind of a private deployment model and a consortium. In a private deployment model, you have a single administration entities or group responsible for administering at a high level, and all VMs are deployed in a single organization. In a consortium model, you have full decentralization, where there is multiple admins that basically control their own instances and separate directories. Optionally, could have some federation if necessary, but there could be separate isolated directories. And then each instance is running in its own organization. And this is something that you could deploy for maybe multiple government agencies or foreign sharing. Let me show you what it looks like. So we start here with a private blockchain where you have platform managers that you deploy, and you define the admin for the instances. So there's platform admin, and then there is instance admin. So you can separate those roles, and they create their instances, and then they join them into network. And then you can define instances within your organization for the specific sub-organizations, if you will. And then they go ahead and create the instances, and then they link them into a blockchain network here. So there is a single platform admin and multiple instance admins, right? And that's a model that works for a number of cases. But if you want full decentralization, then you would come over to the right-hand side, and you can deploy platform managers in each of the organizations, and each one can deploy its own instances with own complete control over instance admins. And once that's done, then you create a production blockchain network linking those instances, right? Essentially, one instance is kind of classified as a founder because it creates a basic what's called system channel, and then other instances can join into that network. And there is a process a wizard used to exchange cryptographic materials that allows them to join, right? So everything, by the way, in a network, just so you understand, is completely protected by encryption and authentication through TLS 1.2. And at the same time, all of the messages are digitally signed. So every message exchanged between the organizations here is going to have a digital signature from a private key, and it's going to be verified. So the member has to be pre-registered on the network, and there is a positive verification essentially to ensure that that member is in good standing. We also provide capabilities around certificate management and revocation. In case the certificate is compromised, we have ability to revoke it, notify all the members it's been revoked, and issue a new one. So that's also very helpful built-in capabilities, because things do happen, and certificates and private keys sometimes get compromised and need to be revoked and replaced. So those are the different kind of deployment topologies that you could use with our Enterprise Edition. So to summarize, we have a lot of work that we put in combining the community efforts, right? So we start with a verified community edition. We're currently working on 1.4 version of Hyperledger Fabric, and adding a lot of Oracle value add points without compromising compatibility in any way, but ensuring that it's easy to deploy, manage, operate, integrate with on-chain access control list capabilities, which is unique to Oracle, ability to use SQL for rich queries, ability to push the data into an Oracle database for analytics and other needs, automated DevOps, flexible deployments, all of those things that add value to the standard kind of open source. But at the same time, it's very easy to interoperate with open source as well as with other vendors' flavors of Hyperledger Fabric. Let me take a few minutes. This is just, I think, a closing point here on the different topologies that are possible, right? So you can build a complete on-premise network in your data center, and you can mix, our Enterprise Edition and Fabric open source if you'd like. You can build a cloud-based deployment, and you could build a hybrid deployment where you have some Enterprise Edition instances in your data center and some running in the cloud. I know there is some work we're doing in government cloud environment to provide national security environments and so on as well. So in the future, it might be an option. So complete flexibility, and all of them are very easy to use based on the pre-built pre-bundled capabilities in the platform managers. Now, let me take a few minutes and talk about our adoption and sort of customer momentum, what we have seen. Our first cloud platform is about 2 years old. It's been available in general availability from July of 2018. And in the last 2 years, we have about 250 customers on it, around a quarter of those running production workloads, and others are pilots and so on, and another 200 or so that are trials, kind of free trials going on. You see some examples of the more popular use cases around things like cross-border funds transfer, loyalty programs in banking, asset tokenization. Supply chain has been very popular. Shipping, trade compliance, provenance, traceability, for conflict minerals, for food, fashion, those types of typical use cases. Government, we've had a number of different government deployments as well. We're working, and we'll show you an example of the project we recently completed with DoD, Army Analytics Group, and Defense Counterintelligence and Security Agency. I mean, we don't popularize it here, but I think for this audience, it's okay to talk about it. And healthcare, we're actually doing some interesting stuff in healthcare, including some work right now underway with Health and Human Services Department for COVID-19 test results tracking as they come, as the data gets reported in from various labs and at-home test kits and all of that. So let me show you a little bit more detail, some of the use cases and deployments here. Starting with things like supply chain provenance. By the way, the ones in bold are all production. The ones that are not bolded are, in pilot to POC form. So provenance in supply chain, things like trade documents, registration, certificates of origin, country of origin, sourcing in, retail supply chain. Volvo Cars is using us for the electric vehicle battery sourcing. There is a lot of processing that goes on with cobalt that sometimes gets mined in Congo and other unsavory places, and they want to separate the sources of cobalt from mining and recycling from legitimate and illegitimate sources, and track that on blockchain as it goes through half a dozen or so different companies before it gets turned into the anodes that then get put into battery units and become, batteries in Volvo electric cars. Volvo takes sustainability very seriously. And there is a number of other companies that are coming into this traceability mode as well. Food, particularly things like extra virgin Italian olive oil. I don't know if you know this fun fact, but about half, 50% of what you see on the supermarket stores as extra virgin Italian olive oil is neither extra virgin nor Italian. Italy exports about half of the real oil and the other half is fake. And so they're trying to fight that. And, we're doing our part, providing blockchain capabilities. We worked with companies like GE on intercompany billings. They have a lot of business units that bill each other, and all of the invoice and purchase order reconciliation across those and settlement is something they wanted to convert from a mainframe-based monolithic system to a blockchain environment. We did a pilot with them. Luxury goods tracing. So Everledger, which you might have heard about, which is doing diamond traceability, is running on our blockchain. Beretta Firearms did a pilot with us for premium guns. Maritime shipping documentation from CargoSmart has been another one. They have a consortium of container shipping companies and ports, handling about half of the worldwide container shipping capacity a year running on our blockchain. Financial services, things like cross-border funds transfer, KYC solutions for identifying customers for onboarding purposes. And then in the government space, including some in national defense, we worked with Singapore Defense Science and Technology Agency to track access for civilian visitors to military bases and facilities and provide kind of access granting tracking on blockchain. And we'll show you a demo of this project with Army Analytics Group on tracking AI, machine learning models and training data sets on blockchain, and a number of other ones here that you see as well. Let me go ahead and talk about this particular example with Army Analytics Group and then turn it over to Rajesh to run a demo for us. So this was a project that started about, about 6 to 8 months ago. AAG and Defense Counterintelligence and Security Agency are in the business of creating machine learning models for various customers within DoD. There is this issue with what's called explainable AI. When you run a machine learning model and you get results, you want to know that it's going to be consistent, right? So when you run it multiple times, you're going to get consistent results. And you really need to know that results are going to be explainable, that you're going to be able to determine that they don't suffer from any bias, right? And that they're transparent. Models in things like granting security clearances, predicting whether somebody will get one or not based on a lot of input data. Models related to healthcare, right? Based on somebody's health history, projecting certain outcomes, all kinds of things, right? There could be, all kinds of issues. And in order to ensure better reproducibility and ability to justify the results and show that in fact they are unbiased, they wanted to track the specific training data sets that are used to create those models, right? A model basically is nothing but, a set of Python scripts and code that gets trained through exposure to a variety of data sets. And when you expose them to different categories of data, you would end up with different model generated and different results. So we have essentially worked with them to help capture the models they develop, the training data sets, to create an auditable track of those different models. Oracle consulting team worked with them on this POC using our Oracle Blockchain Platform Enterprise Edition on premises to capture the relevant metadata, to capture the hashes of all of the artifacts, the data sets, the models, and the results, and enable tracing, linking them together so that there is a way to show that this particular result is generated based on this version of the model and this set of training data sets that were used to create the initial model. So this is kind of what it looks like if you think about different roles involved in this process, right? There is people who do data aggregation and create the initial data from, different attributes, data sort of aggregation, cleansing, and then, they create the actual data sets that are distributed to model creators. And that's captured in a data set anchor on blockchain. Then there are data scientists that create the models, right? And so they refine those models as they create hashes and publish them to validate and recapture that information on blockchain. There is validators who test the models against other data sets. You don't want to test against the same data set that was trained on because you know already what it's going to generate. It was built for the data set. You now want to give it different data sets and validate it there and see if you're going to get consistent results. And then the model ultimately published to the clients. And when the model consumer or client uses it, they generate result sets. And those production results are also being traced. And so all of that is now linkable on blockchain to show that, it's consistent. And the provenance, right? Where did these results come from? Well, they came from this model that was validated with this data and trained on this data. And all of that is on chain. So, and that's done through a web client. Let me turn it over to Rajesh to actually go ahead and take us through a quick demo.
Yep. Hey, real quick, this is Jason. I think we had one question that came in. Bill, I don't want to steal your thunder if you want me to cover it.
So we can go ahead and
have
do it now.
Rajesh start, switch over, and we can answer the question meanwhile.
That sounds good.
Here, should I stop the share?
Yeah, go ahead, stop the share, and let Rajesh share. But there was a question about where, from the ledger, and I think I didn't see it on Q&A, but I think it was in chat.
I can read it to you, Mark. It's what is a KV, as in Kilo Victor ledger? Both Couch and Berkeley DB were mentioned, which is the type I need to look at.
So the KV stands for key value. So the way the data is stored basically is in key value sets. So there is a set of fields, values, that are linked to a particular key. So it's not a relational model, it's a key value model. And the ledger is actually stored in two ways, right? So you have the blocks. The ledger is a set of blocks, and that's stored in a file system as individual blocks that are linked together. And then the current values for all of the keys are stored in the key value database. And in Oracle, we use Berkeley DB. We allow a CouchDB query language on top. So there is a set of APIs that ultimately are the same inside our implementation that talk to Berkeley DB, but we provide for developers ability to use CouchDB query language, which is standard for Fabric, as well as SQL select statements, which is a little bit more unique to Oracle. But in both cases, the actual implementation under the covers of the libraries talks to Berkeley DB, which is where we store the key value sets. All right. So here to take more questions, but let's go ahead and turn it over to Rajesh to run the demo for us.
Sure. Thanks, Mark.
So before going into this demo itself, so this is like at a high level, this is the architecture, right? As you can see here, the magic sauce is all in this blockchain enterprise platform. Because the platform encapsulates so many things, we did not have to worry about all of that, and we were just able to focus on the business application itself. So we provided like a web client. Essentially, when one of the actors, whether it is the data scientist or validator or any one of them, when they are ready to publish the model, they can use the web client to publish that information into the blockchain. And we also have created a Python client. Essentially, the idea there is the data scientist will be able to automatically publish the model to the blockchain as and when they are ready towards the end of their process or validation, so that they don't have to go through the web client.
Right.
So having said that, so before going into the demo itself, like Mark was saying, right? So there is a platform and there is the instance itself, right? So basically we have two primary consoles, the platform console, which is where we have the main instance created and the corresponding configuration. And so this is the application console. So essentially this is where you can maintain the different networks as well as the peers and the channels associated with that network. So in this case, we created one network, Army Update 2, and then we have a number of nodes. Basically, these are all sample nodes here because this is not connecting to any live partners at this point. And we have one channel, Army channel. Essentially, again, the whole idea here is to be able to publish the information about the AI models. And that channel is associated with a chain code, which validates the information that gets published onto the blockchain itself. So that's at a high level.
Chain code is just a synonym for smart contracts.
I'm sorry, what's the question?
Yeah. And I was just saying the chain code is just a synonym for smart contract.
Oh, yeah.
Let's go ahead and start the demo itself because we're short on time.
Sure, yes. So, so basically from a web client perspective, this is what we have created, right? So essentially we have users with different roles. You have aggregator, data scientist, validator, and consumer. So in each one of them, as Mark was showing, would be publishing different kinds of information based on where they are at in the flow. If you consider like data aggregator, all they are doing is publishing information, the data sets, and the data scientist is where the model is going to come into play, and the validator is going to take that model, run through some queries, run through some iterations. Sorry.
Let's go ahead and run it, yeah. So
okay, yeah, sure.
You already explained it.
Okay. So basically, in this case, we would have the data scientist submit some information. So basically, they choose what is the model that they want to publish and the corresponding model files. Essentially, this is where they select the file that they want to publish, and the application in the background creates the corresponding hash and writes that specific model to the file storage that I was showing earlier, and keeps a link to that file storage and publishes that to the blockchain. So all of that happens through this console right here. And essentially we just go through the different files and then the publisher name and the other metadata that is required to publish into the blockchain itself. So now you can go back into the console, go to the corresponding channel and investigate and see whether the information is published or not, right? So as you can see here, this is good to see that, hey, all of this information is there, but it's not as, it's not user friendly, and probably you might not want to give this access to your business users. So this is where the query capability comes into picture. So we have created a query screen wherein the user will be able to query the records that get published on the blockchain using the metadata that's published on the blockchain, right? So again, pretty much everything in here uses the REST API that Mark was talking about and retrieves the information or publishes the information to the blockchain. And as you can see here, the hash corresponding to the model and the data set and the corresponding metadata is available. So if someone sees that there is a discrepancy, they can first check if the hash matches corresponding to that model that they are looking at. And if the hash matches, then they can look at the data set. And within the data set, again, there could be, the data set itself could be different, but metadata could be same. that's why this metadata is key for us to validate if the information is, if there is a discrepancy between what user is doing versus the model itself. And like I was saying, the same thing they will be able to do from a Python script. Essentially, the Python script that we have created leverages similar API, and it can be embedded within the AI/ML model programs that are created by the data scientists. And this is the high-level deployment architecture. Pretty much everything runs within the Army data center. So we have one primary, the Army is going to be the primary node, and then we have a couple of members that we are representing here, but this could be any number of members. And we have one platform manager that will be managing all these different instances. And this Tomcat server is where the web application is running. And this DB server here is where we were using the connector that is provided by blockchain to export the data so that they can run additional analytics on top of that information.
All right, great. Any, thanks very much. Any questions on the demo or, you know, what you've seen so far?
Doesn't look like it, Mark, so we can keep on moving.
Okay, let's go ahead and move forward then. So I think, Josh, if you can share back the presentation, you have a couple more slides in there. So let's move forward. Let me see if I can, I know what I need to, okay, yeah. So just a couple comments here on the new capabilities that was announced recently around blockchain tables, right? So, you know, not everybody wants to stand up the entire blockchain infrastructure. There are many use cases where you might want to be able to simply do some basic blockchain-like things in the database. And so we provided capability in Oracle Database 20C version, which is essentially providing a subset of blockchain properties suitable for centralized use cases where what you really care about is tamper-proof data and transaction history, but you're not necessarily looking to distribute things, you know, across multiple nodes. It helps to basically provide greater data resiliency options for database users, but creating tables, specifically called blockchain tables, that are insert only and that create this cryptographic hash linkage between the rows, which you can then use to validate that data has not been tampered with. It essentially allows you to do those basic type of blockchain use cases using normal database tools, programming models, SQL operations, any client, you know, interfaces, JDBC, ODBC, what have you, and you could mix and match blockchain tables and regular tables in the same queries, transactions, and so on. So on the next slide, we go into, let me see if I can click over there. I need to request remote control, I think. So as I said, it's an insert-only Oracle table. It's coming with a new DDL. So there is a new statement that to create blockchain table and a couple of parameters on auto table. If you're familiar with Oracle database, there are some PL/SQL function packages. And this basically creates a table where the rows are linked with a secure hash. And there are functions that allow you to verify that that hash chain has not been broken, right? And optionally, you can have users sign and verify the row contents and the hash to protect against, you know, what we would call, you know, provider or admin fraud. So you could have, in addition to the database hashes, you could have user signatures created with their own private keys added to each row. Because it's an insert-only table, right? A lot of operations are restricted. You cannot update rows. You cannot delete rows within a set retention period or whatever. So this is configurable. In a real blockchain environment, the data is immutable and blocks are added and never deleted. In a blockchain context, we actually do allow you to define, if you want optionally to have a retention period where you are prohibited from, anybody is prohibited from deleting the data. But beyond the retention period, the data could be deleted. You could, of course, not use that and have data that's never deleted. But if you say, you know, I only want to keep it for, you know, 90 days or 1 year or 10 years, you do have ability to have that retention period defined. You cannot drop and rename columns, add columns, etc. So this is an environment that's very suitable for centralized models where you might have situations where, you know, an organization runs a ledger and other parties use it, but, you know, maybe it's a central bank or trade exchange or, you know, other kind of situations where there is a neutral service provider that is trusted and everybody then contributes the data as users. That's essentially what the blockchain tables provide. And that's available directly within the database without having to stand up any new environment capabilities. Now, let's talk a little bit about how we can help you get started on a blockchain journey. There is, of course, a lot of you know, organizations that are in different places in terms of their own experience, whether they've started already exploring some use cases or they're just beginning to understand where blockchain might make sense. So we can help in a variety of ways. We can start with early discovery discussions, helping to run some more detailed workshops to help you understand the blockchain, for us to understand your particular needs, look at some specific use cases, maybe have done, you know, share what's been done by others, like the SARM Analytics Group. It basically provides an audit trail for the software development. Happens to be machine learning models, but really could be any kind of software assets or digital assets, really, data sets, etc. To an environment where we can actually design and build an initial prototype for you or with you in a matter of a few weeks. Everything that I've talked about, making it easy and so on, is aiming at this final benefit of being able to get in and out of a POC environment, literally in a matter of a few weeks, maybe, you know, a month and a half at most, depending on the scope, of course, of what you want to build. But people want to feel and touch and explore what the blockchain environment really means. And, you know, they may or may not have a really, you know, solid use case to begin with. So ability to do this quickly and fail fast if necessary, right? Try something, and if that's not exactly the right use case, if it doesn't quite work out, okay, adapt it, evolve it, go to something else, but don't spend a ton of energy, don't spend a ton of money and resources on it, is what we're trying to help users with, right? So we can take you through this process. You know, if you already have some use cases in mind, they can start with a design thinking workshop and kind of help to design the blockchain to support that use case, and then go on and implement prototype or work with you to help you, or work with partners like ESS to implement the prototypes for this. So the typical project looks something like this. There is an exploratory stage, starting with a discovery workshop, where we identify the requirements, the use case outlines, kind of define the scope and the benefits, and identify the subject matter experts. We then go through the implementation based on resources and a spec of some sort that defines the data, events, participants, implements integration points, whether it's REST APIs, client SDK, or adapters of various sorts. The front end that you saw in this particular demo was a very simple front end that we built. And then we actually can help you take it to the next phase if you want to broaden it to a pilot with other organizations or other teams within your own organization, evaluate it, test it, and then fine tune and scale it ultimately for go live production environments. So with that, we'll pause here. If you want more information, we have a lot of information on Oracle website. There is a lot of web material. You can go to oracle.com/blockchain. We have a very active blockchain blog, and we have a developer site. If you want to get more technical, there is a developer ebook that walks you through a lot of details. You also are welcome to download the Enterprise Edition on your own and play with it. There is free development licenses. And, you know, if you're inclined, you can try our cloud version as well. We can work with you in either mode and, you know, help you explore it just as an evaluation point. Or if you have certain use cases and you want us to, you know, sort of help you envision how a use case could be mapped to a blockchain, we're happy to engage with that as well. And you saw the team, right? So with that, we'll stop and open up for any additional questions.
All right, well, thanks, Mark, and thanks to the rest of the Oracle team there, Josh, Jason, Rajesh. A couple things there that I picked up on. The discussion on Hyperledger, people should pay attention to. The next tech exchange we'll do is going to be on open source, and we're going to focus a little bit on Hyperledger Burrow. You know, you'll notice that we keep coming back to Hyperledger a lot for the actual blockchain network, because that's excuse me, as Mark said,
Yeah.
at least almost 49, 50% of people out there use it. So it's kind of the big player in the market there.
Yeah, I mean, Hyperledger is kind of an umbrella project organization, and there is a number of different frameworks and tools underneath, right? So you have a bunch of different components within Hyperledger that, like you have Fabric and Borrow and a few other things which are more frameworks or add-ons, and then there's tool sets and a lot of capabilities.
Right, right. And another thing is that we talked about the on-prem, or Mark talked about the on-prem version. We do have that in our software lab. So if we have anybody that at ESS that wants to get their hands dirty, we can do that as well. Right.
Hey, Bill, this is Jason. We've got one question in Q&A and another in chat. Just heads up.
Yep, I'm seeing those. We got one question.
Let me touch on those. Maybe for a couple of minutes we can talk about those questions. So there was one about MVP. What is MVP? MVP stands for minimally viable product. It's simply a shorthand for creating an initial, if you will, scope, right? That has sort of the basic functionality, minimally useful functionality that you could actually stand up for a proof of concept or a pilot, right? So just a way to define some initial scope. There's a question here on why can't you use insert or select to initially load a blockchain table? Oh, that's a good question. Certainly somebody who understands the database environment. This is just from an implementation perspective, something that in the initial version, we didn't have a chance to implement, but it is coming. So we will be able to support insert or select. We're basically selecting data from some other table and then inserting into database. There is no technical prohibitions on it. It's just a question of getting it implemented. And you should see an update coming this fall with, I think, Oracle Database 21c, which should have that capability. On the Q&A, we have a question about how would a BC implementation work in a low bandwidth intermittent network like at CO Mobile. That's a great question from Tony. So, we've had some discussions, obviously, with Navy, as you can imagine. And the question is, when you have intermittent communication and outages and so on. So blockchain is generally built for asynchronous communication environments, right? Different nodes of blockchain don't have to be in absolute synchronization in real time. They have ability to catch up from nodes if they have a communication outage. There is what's called a block height. The length of the blockchain, number of blocks, is referred to as a block height. And every node can check if its block height is lower than other nodes and get those missing blocks from other nodes over time. So it's all built for a synchronous environment. Of course, it sort of depends, on the specifics, right? If your connection is intermittent once in a while, that's one thing. If your connection is intermittent mostly, and you only get a few limited connection points, that could make it more difficult. But fundamentally, there is what's called a gossip protocol that allows the different nodes to communicate and update each other when they can reestablish communication.
Great. The questions that George keeps coming up with, he's our Oracle DBA guy that's been chomping at the bit to get a hold of your 20C database to really see what those blockchain tables do. So I don't know, maybe
we could do that. We could set it up for him.
Maybe we talk about doing another presentation or something at some time next month or whatever that's more specifically about blockchain tables and the database.
Yeah, absolutely. Glad to do that.
Good. I mean, the other thing that I was interested in was the help you guys have on like the design thinking workshop. So I'm going to be back in contact with Jason and anybody else that I need to talk about a GIS pilot we want to do with the Oracle blockchain tables.
Great.
All right. Well, that was a lot of information, a lot of good information. I really appreciate you guys taking the time today to do this for us and present it to everybody that showed up. We had a good number of people that attended, so that's good too. I don't think we have any other questions. So, and we are just about at 3 o'clock. So unless anybody over there at the Oracle team has any last things they want to wrap up on, I think that's a good place to call it quits there.
This is Jason. Just wanted to thank everybody again for sticking with us this afternoon. On screen is our collective team's contact information. The national security group members that you see there were either cleared or clear badged. And if you come from a different account space that we represent, we can certainly put you in touch with the right people. And we'll be happy to field any questions should you have any follow-up.
Yep, you can either contact the people there directly. If you want to get in touch with anybody at ESS, you can email me, or you can email our lab email, which is innovation@exceptionalsoftware.com. And then hopefully we will see everybody again in 2 weeks for the open source blockchain discussion. All right.
All right, great. Well, thanks everybody again for joining. Have a great Friday and weekend, and look forward to reconnecting.
Yep, everybody take care. Thanks a lot.
Bye-bye.
Bye.